Okay, so two things we are trying to accomplish today besides getting a chance to practice AP free response questions. I'm also gonna discuss about one simple concept which you have seen in the past. That is the average value of a function. Now, first, what is the average value of a function? Think of the average value of a function as just an average. So, this is the definition for the average value. Recall that the integral represents the total value, right? The total value of something. And if you take the total value divided by the time, the interval, then you get an average. So for example, say if f was a velocity function, then the integration would represent the total distance, and the total distance divided by the time, that would give you an average velocity. So in general, we just say that it's an average value. This is the definition of average value, so remember this. This is going to come up a lot, especially in AP free response questions. Let's do a couple of examples dealing with the average value. So find the average value of this function on the interval of 0 to 3. By definition of average value, we are going to set it up as the integral from 0 to 3 of negative x squared over 2 dx divided by 3 minus 3 take away 0, which is 3. Let's find out what that integral what this definite integral equals to. So we'll leave the denominator alone for now. Let's just work with the numerator. First, we find the antiderivative of that, and that gives us x to the third over 3, but with the 2 that's already at the bottom, it becomes 6. And then we evaluate that using the lower and upper limit. So this equals to, plug 3 in there, and then you subtract, and then there was a negative there before, thus you get negative 27 over 6, and that is the total net change of that integration. And now to find the average value, you take whatever that number is and you divide that by 3. So average value is negative 27 over 6, divide that by 3, and that gives you negative 27 over 18, because to divide is to multiply by the reciprocal, so therefore you will end up multiplying 6 and 3, and that's how you get 18. Now 18 goes into 27 one time, and therefore you're going to have a remainder of 9, and the remainder of 9 out of 18, that becomes 1.5, and that is our average value. Graphically, what is the average value? Well, we knew that the average value is 1.5. So if I were to create a function that's equal to 1.5, which is a function that equals to the average value, then here's the relationship between the average value and the original graph. If I find the area under the curve of the average value, which would be a rectangle, then that area would be the same as the area under the original graph. Now this is the original graph, and the area under that graph will be the same as the area under the average value curve. And that's the meaning of the average value. It's an average value so that the area under its curve is the same as the area under the original function. Find the average value of this function from 1 to 4. So let's go ahead and set it up first, and then we'll do the computation later. So average value is defined to be, by definition, is the integral from 1 to 4 of 3x squared minus 2x dx, all divided by 4 minus 1. So let's go ahead and find out what the integration is, and then we'll divide that by 3 later. So on the side, we're just going to find out what this is. The antiderivative of that, it's going to be x cubed minus x squared, and then we evaluate that from 1 to 4. So when we plug 4 in there, we get 4 cubed minus 4 squared. So that's my kind of like my first term, and then I subtract that to 1 cubed minus 1 squared. 4 cubed is going to be 4 times 4, that becomes 16. 16 times 4, that's 64. So I get 64 minus 16. 64 take away 16, that gives me 48. So then I have 48 over here, and then 48 minus 0, so therefore I get 48. So that integration is 48, and then I divide it by 3, and 48 divided by 3, 3 goes into 4 one time, and 3 goes into 18, which is what's left, is 6, and therefore the average value is 16. So if I were to find if you take 16, if I take 16, multiply that by 3, I will get 48, which is the area under the curve, because that area under the curve is 48. And so that's the graphical interpretation of the average value. But what I want you to get from this concept is, whenever you see someone or a question asking for the average value of a function, then I want you to think of this. So now we can move on to our first exercise on how to deal with AP free response questions regarding the fundamental theorem of calculus part 1 and part 2. In a typical problem regarding the fundamental theorem of calculus, you will be given, it could be a function, it could be a graph, but most likely you'll be given a graph, and they'll define a function using an integral, and now they'll ask us to find some of these, like function output or the derivative. So let's do one of these. Let's do 3 of these together. So here's the function g, and here's the graph of f. Function g is defined to be the integral from 0 to x of the graph of f, and they want us to find g of 4, g prime of 4, and then g double prime of 4. So let's do g of 4 first. So g of 4 is, here's the definition of how to find g. So you would find the area from 0 to 4, because wherever x is, that's where that value is. Maybe I should highlight that so that you can see what I mean. And now, to know what this value is, I look at the graph from 0 to 4. So here's from 0 to 4, right? From 0 to 4. Here is from 0 to 4. So that includes this shaded region, the area of that shaded region, and also the area of the shaded region. Now, the area of this shaded region is going to be a negative number because it is below the x-axis, and so the area of this triangle is -1. This figure is a trapezoid, and the area of that trapezoid is 1/2 the height of the trapezoid, which is 2, times the 2 bases, and these are the 2 bases, the short base and the long base. So the short base has a length of 1, and then the long base has a length of 1, 2, 3. 3, so 3 plus 1 is 4, so it has an area of 4, and so if you combine those two together, from 0 to 4, that has a net value of 3. So we know that this equals 2 to 3. It also asks us to find the derivative at 4. So we need to first find what is the derivative function. Well, remember that by the fundamental theorem of calculus, part 2, the derivative of any function defined by an integral is just the inside function, it's just this function. But the only catch is you replace the letter x with the letter t. So I know that g prime of x is f of x. So now, if we want to find g prime of 4, then we replace the letter x with the number 4. Now, this is the graph of the function f, so I look at the graph of function f, and I want to know what is the function output when the input is 4. So when the input is 4, the output is 0. So this has a 0 output. So this equals to 0. Before we can find the second derivative, we need to find the second derivative function. This is the first derivative, so the second derivative function is f prime. So the graph of this is the graph of the first derivative because g prime is f. So the graph of the second derivative will be the slopes of the graph of the first derivative. So g double prime at 4 equals to f prime at 4. So I need to look at 4, and in order for me to evaluate this, I need to find the slope at 4. And if you look carefully at this segment right here, the slope of this segment is the second derivative of g, because that's what it says. So what is the slope of this segment? The segment rises. I rise from here down there. I rise -2, and I run 1, which is -2. So I know that that equals 2 to -2. Okay, so these are my answers. G of 4 is 3, g prime at 4 is 0, and g double prime at 4 is -2. I'm done with part A. I'm going to move on to part B. So part B says, does function g, which is this function, have a relative max or relative min at 1 or neither? So if it has a relative max or a relative min, then 1 must be a critical point. So let's first check and see if 1 is a critical point. So we know that g prime is equal to f. G prime is equal to f. So this is the first derivative of g, and the first derivative of g is used to find the critical point. So what this says is that the first derivative of g is the graph of f. In other words, the graph that we're looking at here is the graph of the first derivative. So to make things easy, you can always cross that out and just write, oh, that's g prime. This is the graph of the first derivative. So the graph of the first derivative, we need to check and see if 1 is a critical point. And clearly at g prime at 1, this is g prime at 1 right here. G prime at 1 is 0, so it is a critical point. Now g prime is negative to the left of 1, and g prime is positive to the right of 1. So the sign graph. So here's what we know so far. We know that if I were to create a sign graph for g prime, then 1 is a critical point, and then to the left of it it's negative, and to the right of it the derivative is positive. So that is a min. That's a min. Again, to the left of it is negative, to the right of it is positive, so that's the min. So does g have a relative max or relative min? G has a relative min at x equals to 1 because g prime changes from negative to positive at x equals to 1. Now the last part is part C, so let's go ahead and do part C and see what we can come up with. So here's what it says. Suppose that f is defined for all real numbers x and is periodic with a period of length 5. So if you look carefully, the graph, this generic shape of the graph, it repeats itself every 5 units. Every 5 units it repeats itself. The graph above shows 2 periods of f. Clearly there are 2 periods. This is 1 period and then there's another period, so there's 2 periods. It is given that g of 5 equals to 2. So g of 5 equals to 2. Find g of 10 and write an equation for the tangent line to the graph of g at x equals to 1.8. So there are 2 questions here. It says the first question is to find g of 10. And the second question is to write the equation of a tangent line to the graph of g at x equals to 1.8. So let's tackle this question first, and then we'll tackle the second question later. Okay, so to find g of 10, so g of 10, this is part C, right? Part C. To find g of 10, we set up the integration, the function from 0 to 10 of f of t dt. That's how we find g of 10. Now, because g of 5 is given to be equal to 2, g of 5 is given to be equal to 2, and also keep in mind that this is a periodic graph, which means that it repeats itself. All right. So two ways to think of this problem. We can think of it as from 0 to 10 of f is the same as 2 of these. It's the same as 2 of these because there are really 2 of those. That's one way to think of it, and if that's hard for you to visualize, then maybe this might be better if you split it up from 0 to 5 of f and then go from 5 to 10 of f. Then maybe that's easier for you to understand, because property of definite integral allows us to split it up, and this first expression is the same as g of 5, which equals to 2. Okay, now what is the value of this second expression? Well, remember, this is periodic, so every 5 units it repeats itself. So in other words, this part of the graph is exactly the same as the part from 0 to 5. Therefore, it's going to also have a value of 2, and therefore g of 10 is equal to 4. Write an equation for the tangent line to the graph at x equals to 1.8. Now x equals to 1.8 is a really big x. It's all the way out here, right? It's all the way out here. But remember that this is a periodic graph, and so it is easy to identify the exact location of x equals to 1.8, or the output of when x equals to 1.8. In other words, in order to write the equation of a tangent line, we need 2 things. We need a point, and we also need the slope. So the first thing we're going to do is we're going to find a point. Okay, we know that x equals to 108, and so what is g of 108? Well, because this is a periodic graph, g of 108 is the same as g of 3. And I want you to figure out why. And if you couldn't figure out why, then let me know. But here's another way to think of it. take 108, divide that by 5. Okay, if you take 108 and divide that by 5, the reason why we divide that by 5 is it's periodic, and every 5 units it repeats itself. So we divide it by 5, and if you divide by 5, you're going to have a remainder of 3. And that's why g of 108 is the same as g of 3. So that equals to 2. So we know that the x value is 108 and the y value is 2. We also need to find the slope. So the slope is g prime at 108, which is the same as g prime at 3. And remember that g prime is, this is the graph of g prime, and g prime at 3 equals to 2. G prime at 3 equals to 2. So therefore, we know that that equals to 2. Sorry guys, I take that back. G of 3 does not equal to 2. G of 3 means that we have to find it this way. Okay? So G of 3 is the integral from 0 to 3 of the function f dt. So from 0 to 3, if you look carefully from 0 to 3, from 0 to 3, it's actually simple because from 0 to 3 means that, well, from 0 to 2, these two triangles will kind of neutralize each other. And so the only thing you have to calculate is this rectangle, and that rectangle has an area of 2. So it's also 2, but I got it right by accident. I didn't think of it as the function. I thought of it as a point, which is a wrong way of finding g of 3, but it happens to be the same answer. But it's 2. So now I have my point, I have my slope. I'm going to go ahead and put it together. So y minus y1 equals to m times x minus x1. So y minus 2 equals to 2 times x minus 108. And I'm done.